A very good day. The topic for our proposal here today is mitigating scope variability in engineering R&D projects using a decision support system and support model, a proposal and review. Now, this system we're proposing here is for project managers who are in MNC companies doing R&D projects. They have a lot of factors affecting the projects, and we're trying to propose a system that helps them mitigate the scope that may arise from that. So, the topic for today, and we're going to talk about 5 things today, which is the research background, methodology, results, discussion, and conclusion. We'll talk about top to bottom of a very rough overview of what's happening in our project. So we're going to talk about how we proposed it, what we proposed in the first place, the testing, and finally what are future plans. The authors for this are me, Kai, and Dr. Christina. Kai was the one that proposed this idea, and I was the one that completed it, and Dr. Christina is the one that guided us through our entire process. So the research background. What is the problem statement here, and what is our literature review? So the reason why we took on this project is simply because in the industry right now, project managers who are handling R&D projects have a lot of issues because there are a lot of decision factors that come into play when they are deciding a lot of different things for their projects. This may be due to long research projects, research periods, regulations, technologies, uncertainty, management changes, funding, and etc. And it does not help that every year the cost and time taken for R&D projects keeps increasing because of the ever-increasing numbers of variables. So because of that, there is a gap, and current solution industry, which include decision support models and subsystems, do not properly support PMs in industry. So we decided and we recognized that there is a gap and that there is a need to study this gap. So what is a decision support model and support system? In a nutshell, a decision support model is a tool used to support decision making and acts as a conceptual block of decision support systems. And a decision support system is an interpretation of that DSM block and into a computerized information system. Simply put, it allows you to easily access this system in a very visual manner. So the way that we made our system is through 4 steps. First off, data management. We had to do literature research, we had to do our reading, we had to do our interviews, and from that data, we crafted a decision support model. Now that is a conceptual block. That is the one that is the fundamental peg in our system. And from that fundamental block, we designed a user interface, a decision support system. Now that is where PMs can interact with the system directly in an easy manner that is not usually done by other systems. And finally, there will be the testing validation. This will be a crux where people would say, okay, whether or not this actually works, whether this actually proves out in thin air. So that's our rough overview. So our research has 5 main objectives. You can read more about it, but roughly, the research background, we're doing this for PMs who are doing new product development because these projects have a lot of variables and we need to properly address the gap in the industry. Feedback and PI are what is important in the decision support model. PIs are performance indicators, and we decided on a few PIs based on our literature research and based on our interviews. And these PIs are put into a prioritization method, and this is what is proprietary. We designed it based on our interviews and our literature research. And our DSM and DSS solution is something that is the key part of our research. We decided to address the shortcomings of current systems. And finally, to cap it all off, we have the verification and validation testing. This is where we properly say, okay, whether or not this actually works in industry. And if it works, how else can you further improve it? So the methodology. How do we design the system? The idea management, the proposal, and finally, how was this done? There's a SWOT analysis, the DSM formation, and finally a DSS formation. The SWOT is done through the comparison of selected DSMs. And from that SWOT system, the DSM is formed. We identify performance indicators and what is the relationship between these factors. And finally, the DSS formation. How can we integrate this SWOT analysis, this idea management, this DSM into a piece of software? So we designed the software to be a PWA, a progressive web application that can use across any platform. So before we start using a DSM, we decided, okay, there is a need for us to properly sort out ideas. So there has to be overarching principles and an idea management methodology. So we decided on 3 things. The first off, Agile. Agile helps you to modularly decide on what's important while involving stakeholders in your discussion. Science-based partnerships helps you to stay ahead of the game, helps you try to mitigate people in industry who may be having a leg up on you, because you have people in industry, people who are institutions trying to do research for you. And that collaboration is really important. And finally, the crux, the idea management, SWOT analysis. We have decided on SF Lee and Sion's Sun Tzu's art of business management, and we decided this system is important at this point of time. It has been proven, and we think it's really important for PMs to at least have a sort of idea of how to manage their system or manage their ideas before going to the DSM itself. The DSM formation has 4 important steps. First off, the comparison of selected DSMs. How do we compare against DSMs in the industry which are more suitable but still have shortcomings? Secondly, the interview. What do PMs want? Because they are the ones we're catering this project to. The generation of PIs and DSMs. So after we've done our interviews and our literature research, what is important, we have to make sure we gather a list, and from there we go back to PMs and say, okay, what do you want? And finally, testing and case studies. We have to have long-term monitoring, and that's something that has to be done in future research as well. We have to have long-term monitoring of what's important and whether or not it actually works in a very, very long span of time. And finally, our DSS formation. Our DSS is done using a progressive application, using a ton of different complicated words, but in a nutshell, it uses React.js, and it works off a very simple system architecture. It uses use case diagrams, activity diagrams, and finally, after we've done all this mapping of what's important and what the users actually want, we launch a beta version. We have people test it, and then we launch the final version for people to use it. Now I'll pass on to Kai for the results.
Hi, I'm Kai. I'll be carrying on with the results section of our proposed DSM and DSS. Studies show that a variety of factors affect human decision making, especially in volatile and high-stakes situations in engineering and R&D project environment. So this is a comprehensive stage for us to decide what is important quantitatively so that it's easier for users to apply the DSM. So there are many alternatives and different systems tailored for different people, different industry, and different needs. And the system that we're suggesting, as mentioned by Dhipan just now, is based on a concept by SF Lee and Sion from Sun Tzu Art of Business and Management. From there, we have conceptualized our DSM, which is separated into 2 parts. So this is the part 1, which has the finalized list of performance indicators and their relationships, which are obtained from interviews with more than 10 experienced project managers. Looking at this figure, there are 6 groups of criteria. We have finance, timeline, product performance, production, human resource, and brand performance. And under each of this umbrella, we have the individual performance indicators. So the relationship of these PIs are represented by the arrows in the figure. So for example, an R&D project has overdue tasks and their concern is they're not able to meet the timeline. So the way to mitigate this issue is to possibly change other manipulating factors pointed by the arrowheads in this figure. So there are multiple solutions, as we can see here. So there is a need to find out which solution suits the project best, since different projects do have different priorities and goals. And that brings us to the second part of our DSM, the prioritization of options. So this is done by comparing the PIs pair by pair via a reciprocal value. Since different projects will have different goals and some focus more on quality aspects or brand aspects, some on the others. So at this stage, there is a flexibility to choose which criteria to compare. And the decision support system is a multi-platform system that is easy to access and operate. So the code base allows for easy expansion to platforms like Android, Apple OS, Google Chrome, etc. As long as the browser supports JavaScript. So for user, there is an intuitive user interface for them to easily input and interact with the data. And future versions of this will focus more on how to make the experience more seamless and tailored. Let's move on to discussion. And to obtain the results, we first perform literature review to identify the idea management and overarching principles, to find the best solutions or proposals to manage ideas. And with that, we have our performance indicators and our concept of DSM, which is also developed into a DSS beta version. And the model has been used in 4 separate case studies in the MNC product development field in depth to evaluate its applicability and effectiveness. So in these case studies, the project managers pick 2 to 4 important criteria, and then they identified their relationship using our DSM and DSS and performed pairwise comparison with our beta version DSS. So the direction obtained from the analysis using our system actually tallied with the decision made by the project management team. And this proved that the concept of DSM and DSS proposed by us is valid. However, there are still some aspects that our system can improve upon, and first being monitoring, where we can perform longer term testing to test the viability and to improve further. And secondly, it would be more conclusive to expand to different industries and tasks to avoid problems in decision making. So this is also to provide more options in the idea management and also expandability of the DSM. And thirdly, to integrate more real-time data into our DSS, and this can create a more seamless system. And fourth, to include different levels of decision maker, both upstream and downstream in the future. So these are the things that we can improve upon with our DSM and DSS. And in conclusion, we have achieved multiple ROs that we have proposed earlier. And first being the theory, we have analyzed idea management overarching principles of our DSM and DSS. And secondly, from there, we fabricated the DSM and DSS prototype, which is used in multiple tests and case study to evaluate the applicability. And based on the feedback, we were able to address the concerns in decision making to mitigate the variability during an NPD process. So this research has introduced a systematic decision-making plan, which is able to increase the efficiency of the process, reduce the time taken to respond to an encountered issue. So we also integrated it with a digital system. We have idea management overarching principle to future-proof it. And finally, it is also identified that it would be better to expand our system to different industries and to provide more options with the DSM and the PIs. So this is aiming to create a more seamless and integrated DSS for the engineering field and hopefully others in the future. So this is our research on this topic, and I thank you for your time for listening.
All right. Thank you.